Okay, another stream. Been at it for 54 days and got a couple, I guess, of announcements. So I think, so with me kind of being in limbo of not knowing if I'm passing or failing, I'm gonna assume fail, and we're gonna just keep lead coding. I want to also focus on content creation, like super seriously, making good videos, having I have a couple of ideas for videos that I want to do, and I'll try like probably releasing those as shorts because it'll be like less of a time commitment if it's only like 1 minute, a good 1 minute video. So up the quality on that, and set up a stream schedule. I need to set up my like Twitch profile like probably better in a way that looks like somewhat professional. Nice. I don't even have these AirPods connected. The Yeah, I need to have this like my page, I think, somewhat professional. I don't even know how to like even look at the stupid thing. Let's see, what is it? Content? Home? No. Is it just, do I just go to Twitch with my username? Oh my God. Channel, like that? Okay, yeah, so I need to have like the little panels that people have. So like I think people do like they like add little things or something. Free animated panel suggestion box. Yeah, you can add like images and stuff. But I need to like start adding like just random like kind of like stuff like that. Like this, like these things into my stream. So they got like these little panels, I guess, and other stuff, and they've got like extensions and things. And then my schedule too, I think, is on here, but I don't see it. But there's like a stream schedule. Ideally, like I want to start like streaming at a more regular time so that people will know. So that's probably going to be 7 a.m. or 8 a.m. Start streaming and just do like a morning thing. I think there's like enough lead coders out here in the mornings. Like you'll see like Prime again get like 2.1K. I think the same thing with Thor. They'll get like 2K views. And yeah. Yeah. So I think that is it. Those are it for the updates for now. Then we're going to go into some lead code. So pull this thing back over here. I'll figure out how to do that probably later today, and also probably go into like breakdown, or maybe start recording. Should start recording for my video. Probably maybe like 5 p.m. or something. Probably won't be doing 5 p.m. streams, most likely. But okay, so I was solving this problem. Okay, so we had this diagonal. We're gonna loop through every diagonal. So we're gonna create a 1 by 1. Then we're gonna create a 1 or 2 by 2. And then we'll create a 3 by 3. And if it's ever not valid for the sum, then we just break out and we're like, okay, well, if we can't do a 3 by 3, we cannot do a 4 by 4. And then so we just like, okay, get out and return answer, basically. I think we could just return it here, honestly. I think. Like if it's greater than, I think we just return answer here. And then here we just say like if sum is greater than k, and it could even be equal to k, I think, but maybe not. Just if it's greater than k, we'll just return answer. And if it's not, then answer plus equals 1, because that counts as one subgrid. And then we go into the next one. And I think this works. We'll start with the 1 by 1, 2 by 2. This might need a +1. I might be at like some off by 1 errors, but may have some off by 1 errors. We're gonna print these out. So print right max, bottom max, so I can get some debugging here. Invalid syntax, return. we're going to be returning an integer. Then we didn't define sum. So then we get 1, 0, 1, 1. We get 3 and 5. So we're off by 1. Not sure if that's due to something here or not. Let's see. I think for this one, we should have like 1 and then 2. 1, 2. So that could be the case that we're missing it because we skip here, but like we're really, this one should be like incremented. Like if sum is greater than or is less than k, answer plus equals 1, something like that. Same thing here, like if the sum is less than k, then we can count that one as a solution. But we only do that once, really. We only do that once, only count that grid once. So this one apparently works. I'm kind of surprised that this code works. I thought it would have been off by 1. But we'll run it, I guess, and see. The real thing would be if I added in like a case for like 4x4, which I'd probably try to do in a actual contest. I would like just edit this and see if we get the expected answer. It tells us. Oh shoot. It's kind of based. Okay. So yeah, I think our code is good. I'm kind of surprised, but this was the idea that I was going for yesterday. And we'll just run it. And we're wrong. Oh no, got a 5 for this one. Oh, why did that happen? We had 7. If anything's wrong, I would expect it to be the max diagonal one. And I would have expected to want to iterate 1 more higher. This is what my expectation is, that it needs to be +1. But even then, we're still not there. Because the bottom max is 0? How did that happen? And this is like so difficult to actually look at. I'd have to draw this out. This 7, 7. So I would also go like, if this were a contest, I would go to the app diagrams thing, which I don't really like this website. I think Excalidraw is like infinitely better, but I'm gonna most likely just start using that. I was using this one because the DoorDash interview said like that you're allowed to use it, but my interviewer didn't really bring it up, and I also didn't bring it up, so, but it would have been better if I had done that. Anyways, definitely would have gone better because I would have actually just known the commands instead of using the stupid hacker rank. Anyways, so we've got what, like in this first row we have like 7, 7, 1, 5, or 10, 9, I think, and then 10, 5, 10, 3. Right? So the bottom one, I would have expected it to be good. For the columns, these are columns though, not rows. We're going through rows. We're going checking the bottom. And we do it once, but just once, and then we break. Did I flip these? No. Where's my OBS at? Cool. Did... But it doesn't make any sense though. 17, but 17 is less than 54. So that doesn't make any sense, right? Like, I flipped it properly. What? Checking 10, yeah. 7, 10. But then it exits out because 10 is fine. And then we print out I minus. Where's my bug at? Where is this bug at? Let's see. What was the answer? The answer is 5. The answer is 5. So we do 1, 2, 3, 4, 5. And then we should do 6. That's like literally it. So we're just not doing 6. Because we're getting 5. Okay, cool. So let's try to do this. The right side should have 1, 2, 3, 4, 5. That should be the answer. That is 4, but it should be 5. It should definitely be 5, I think. Oh wait, no, these are, no, it should be 4. It should be 4. These are separate. So it would be 1, 2, 3, 4. Okay, 5. After we reach the here, which is good. And then we draw out here. So that would be the other one. This would be 6, but I guess it's doing 7. It includes it as 7 here. Because that's a submatrix. So I just drew this out wrong for the diagonal. Because we want to go here. But then next time go here. So I guess we would just keep adding. Yeah, the code is doing it fine. It's doing what I told it to. The issue was just that there's a case where I have to like think expand this out to go here and then go here and then also try this one. And how do we iterate like that? Because I was just like, oh, okay, we'll go here. We'll go like here. And then we'll go here. And then we'll just kind of like check all of them like this. But I don't think I was ever going around like this. How do we iterate like that? That I hate that these auto connect to my phone. Cool. Cool. So then I'm gonna have to step away right now, like 3 seconds. Yeah, because it's not technically this. Like, technically what I want to do is go here, like start here. Okay, yeah. Meet up for a second. Okay, cool. So I'm gonna go here and then over here. Okay, cool. So we know like this is like the max here, and we know like this is like the max here. So then we just want to, I think this one should count. If we're really doing it that way, then this one should count as a, oh wait, it does. We already counted it. So then we just need to count this one, which we can do by adding this, adding this. And we have to go bang, 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 bang. I kind of, like the only way I could think of having this one is do like a quadruple for loop, but that doesn't seem like that would actually help. Where like, oh, here, 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 here. And then you expand out, but expanding out like that is so weird. Oh my god. Eight, 9, 10, 11, 12, 15. Oh my god. No, but the diagonal won't work. It would have to be add this one and add this one. And it works. We say, okay, cool. And so we add this one too. And we do the same thing here where we add all this ones, add this one, add this one, and see if it works. Maybe just do it right heavy and then another loop for the other one. Maybe. So here we'll like iterate through it, but then we'll just keep expanding it. So we'll do like here. Right, but like instead you go from like R to C. So if over here we go check, 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 which we already did, and then so we do bang, bang, bang. Bang, 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 bang. And then we keep going like bang, bang, bang. No, that's so weird. That doesn't actually make any sense. Oh, why couldn't it just been like actual even, like an actual even thing? Oh. Maybe there's like a other way to think about this. Seven, 9. There's probably like some DP type of thing with this, but oh my god, it's so annoying that I can't solve this. That I'm like just missing like this stupid iteration of expanding out the grid. And I feel like I could probably even break this up. So like I could even like, I can do a thing where I just like go through and then go through. But it's so awkward, man. It's so awkward. Yeah, like this, like it might work if we just get the max. So like here we did the minimum. And it might work if we just do the max this time and do something very similar. But I can't say for sure. Right, like this time we doubled up, we double dipped. We double dipped. So then it doesn't count. Dude, what a problem. Okay, I'm gonna try to, I guess, skip this one and go to the other one. You're given a one indexed integer. We define a function greater count such that greater count returns the number of elements in array that are strictly greater than value. You need to distribute all elements between the two arrays using AND operations. First operation, you would send one array. Second operation is in the other array. And then the ith operation will check the greater counts is less than this one, then we make it for array 1. And then if it's less than, it's array 2. And then if they're equal, then it goes to the lesser elements. And then if there's a tie, we append it to just array 1. They have the same number. The array result is formed by concatenating both of them. Okay, so... Okay, did they give us this function? I guess they didn't. They didn't even give us this function, greater count. Where's the function? It says they defined it, but I don't see it. So then I guess this is just to help explain the problem. It doesn't actually exist. Okay. First thing is like maybe there's just like a prefix something, but like probably not with the greater count, but maybe you could use some kind of prefix sum. Second idea too is you could sort both arrays and then can we sort them though? Are we allowed to? We take the first one, right? You need to distribute all elements such as two arrays. In the first operation, you append nums1 to array 1, and then the second operation you append to array 2. And then afterwards, we're just going to check if the ith number. So like it's going to look something like this, I think. And I'm just going to just write this out. But we'll have like array 1 is nums at 0. And array 2 is nums at 1. And then once again, we'll just be going through the nums, but we're starting at like index 2. And then we're going to basing this off some criteria, which is here, I believe. So like, is it greater than, is it less than, or do they have the equal sizes? And then here, like, this is a good example here, 2, 1. So we put 2 in the first array, 1 in the other array. The next value we're going to look is we're going to try to insert 3. And then we're going to say that 3 is, is greater than, or is it, right, just need to distribute the elements of two arrays. It's the number of elements that are greater than that value. So there are no numbers that are greater than this value. So then we add it to here, to array 1. Because this one fails too, and then we do this one. And then here again, we get 3 again. There are, what is this? The lesser number of elements. So we tie again for the 3, and then we say like, that it goes to the lesser one. Okay. This problem doesn't seem that bad. I don't know. But maybe it is. But, so we can probably keep track of like numbers that are greater than this. Probably like some way that you can calculate this really quickly, because right now this is the bottleneck. We don't want to have to like loop through the entire array every single time. So we don't have to say, oh, okay, well, let's go through all of array A or array 1 and all of array 2 to see which value, how many numbers are greater than this value. So that's, that's one, I guess, observation. And the lengths are like really easy to do. It's just this greater count. Simulating doesn't, I don't think simulating works because we got to go through everything. So how do we quickly count? How do we quickly count? Here, back. Okay. So. We need to get the number of numbers that are greater than a certain number. And I don't think this is always in sorted order. Unfortunately, that is not guaranteed. So without sorting, with sorting, you could do it in like log n. That's actually becomes really easy. We could make a sorted copy of each number maybe, and then we just insert in sorted order. So we have like, so then we'll kind of know at every step. That's probably it, right? So we do 2, and we have the 1, and we put the 3 in, so then we get like 2, 3. But then like we kind of like know, or even in this case might be easier, right? 5 and 14. So we have 5 and 14. The 5 is greater than 3. And so is this 14. But we just put it here because there's a tie. But you could do this by like just like you have like the sorted list. So instead of doing 5, 3, we have another list that's like 3, 5. And then now it's like a lot easier. I think that's the case, right? So we do keep like a sorted R1. And we have like a sorted R2. And then at every step, like we have like the greater than function or whatever, like def greater than or greater count. Right, and we'll pass in like maybe like I guess the array, some array, and then like some value. And then that's going to be like array dot, or is it bisect left? Just like that. And then I think we bisect left because we want to know the smallest area. And then like it'll just be like the length of array from index and onward or something. So this could be 0, or we go all the way to the end. These will be the list of numbers. And then we can just have like this if statement. So like if nums greater than x, but it'll be like it will equal like nums at I. So what we're trying to decide. And actually we'll say like array1 graders, array2 like graders. Have both these things here. And then just do like array1 value, array2 value. And like if store the result, and then just check if it's greater than or equal to. So if it's greater than, then we put in the one that has the fewest ones. And then we're going to do like the sort, in sort, I think, every time. So we keep it in sorted order, or we could append it and sort it manually, but I think in sort is better. So let me actually see this. So I think it's bisect dot bisect, or bisect dot and sort. And then it's like sorted array2. And we'll put the value in. Like that. And then this one should actually be the sorted versions of them. So we can leverage the binary search. And then do the same thing here, but for array1. So array1, and then we flip it. And then we've got like the elif. They're the same length. And the length of array1 is greater than length of array1 is greater than and then we like insort it. I think this is okay for time complexity. And then if any case, then we just do 1. Just add it to 1. And then at the very end, once we finish this, we'll just do array1 plus array2. I think this is fine, right? If it's greater than, you do the one that has the lesser one. Yeah, and then if it's still a tie, then you just append. Yeah. So we can see this. Misspelled it. Nums greater. And I need to open up this OBS. Cool. Int has no length. Int has no length. Why is it an integer? It should not be an integer. Should it be? Surrounded by some brackets. Messed that one up. So here we get 2313, 5314. Oof, that is not good. Almost, kind of. So we got some mistakes. 5, 3 goes 3 went. And then what should happen is we say, okay, so array1, array2, array1. And then this one has 2 numbers that are greater than 1, but this one only has 1 number that's greater than 1. So I misread this. If the count is greater, then it always goes to 1. If the count is greater, then it always goes to 2. So I think we swap these. Yeah, cool. So I think, and then time complexity wise of this, we're just preparing for interview, so we want to be able to write this stuff down. But like, time complexity of this is going to be like O of n on that loop plus O of n plus like the log n, but it's actually n log n because we're insorting into the array every time. So it's like O of n log n, what it's going to reduce down to, which should work for this 10 to the 5th. I think you can do n log n for this. Hopefully this works. I guess we'll see what happens, but it looks like it might TLE. Or wrong answer. Wrong answer. Okay, cool. That took a thing was spinning for a while. What happened? We get 2, 1. Default to 1. So we get 2, 3. And then how many things are greater than 3? How many elements are greater than 3? So do we do bisect right then? Did I mess up? And then we do like bisect right? Because this one probably, I'm guessing it printed wrong. I don't know. IDX. What? Because these should be equal again. That would be my guess, right? Like, right? Like, okay, 0, 0, 2, 3. And then I want to print out like what each array 1 is and array 2 is, just so I can see this live. So we've got 2 and 1, right? That's how we start. Okay, and then we got 2, 3, and 1. But now we're saying like, oh, well, there's 3 ones that are greater than 1. But that's not true, actually. That is not true. So I think the bisect messed up. I think it saw the 3, and it was like, oh, well, I'm going to put you to the left of the 3. And it put it on the left of the 3, but the 3 is already inside, and that doesn't count. So I think it should be bisect. But then we could run into where it's the end index. So then that changes things a little bit. And we need to do bisect. What is this? Index. One we'll just check. I think it might be the same, but then we just check like if index is equal to the length of array. Then we just return 0. I think that's probably it. And then we get 2, 3, 1, 3. Cool. So I think this is it. I'm gonna load this other one up. Was this actually the the base case and I just failed it. I never noticed it. Okay. Okay. Now we're gonna run this again and see what happens. But yeah, definitely was the standard input. I don't know how I missed that. Don't know how I missed that. Okay, we're gonna run this again and see what happens. See if we TLE. Or not. Or TLE. Wrong answer. Oh god. Again. 38 is greater than 2. So it should go on the left, but it doesn't. It didn't. It went with the other two. Big rips. Big rips. That bisect function should work. It's kind of weird that it's not. Zombie killer whale, what is up? Some Leetcode once again on this fine morning. I'm just solving the contest. Distribute arrays into 2 elements. Number 2. Number 2. How much time do I have left? I never did the virtual contest, so I wasn't timing myself. Yeah, was not doing this really to time myself, just like look at the problems. I should have timed myself, but probably that'd probably be a better strategy for like next time and stuff. But if I had to guess, so I solved this one pretty fast, but like I didn't like, I probably spent maybe 10 minutes on this one, maybe 15 minutes, and I haven't actually solved it. And then this one I've probably spent 10 minutes on it. Probably, so something like that. It's like maybe like 30 minutes in total for this contest. 30 to 40 minutes maybe. But also, yeah, I haven't even solved this one. But I think I can just get the solution to this one. I think it's just binary search. Zero, 0, 2, 2. This should not print out 0. Should not print out 0. What the heck? Two? But like the bisect right finds the rightmost location, but this isn't in sorted order, like at all. But maybe it's because it's equal to the length of the array. Really? Do I need a bisect left and bisect right? $38? Oh, it's an empty array. Yikes. Big yikes. Okay, that's the issue. It's not that. It's that. I never added it. Okay, cool. Now it works. Now it's expected. Now it's expected. The way that I thought it would work. Okay, now hopefully this works. We'll see. I don't know. But I think this is O of n log n. Oh no. No, time limit exceeded. I thought this was good. Put it in sorted order every time. And then just bisect. I think there, thinking that there might be some way to just keep track of every element that's greater than another element, but might be some way. This is the real bottleneck, is just this greater count. And then in my algorithm, it's the fact that I'm doing bisect. And then I'm doing insort. This is actually the big one though, is keeping it in sorted order. Because you gotta go through the array every single time. But I don't know if there's another way to maintain a sorted order of elements. Maybe, like maybe with a binary search, or yeah, is it binary search tree? Maybe a binary search tree. Maybe. But I think I think inserting into a binary search tree, I don't think it's O of n. Because it doesn't, yeah, you don't have to like split the array every single time that you're adding it. Yeah. Fortunately, there's no Python library for a binary search tree. But it would improve it, like some type of tree structure. I mean, look, what's like the closest thing to a binary search tree in Python? I'm gonna look this up. Closest, does, let's see. I think sorted dict was like the closest library that it had to a binary search tree from what I read in the other one. What's the closest library or data structure Python has built for a binary search tree? Bisect module, and then sorted containers. Hmm. Yeah, it is sorted dict. Sorted dict. Let me see. Apparently there is I range and a sorted dict. That's like the closest thing Python has, yeah, to a binary search tree. And then if that's not the case, then I would have to like literally implement it myself. But that would definitely get rid of this O of n inserting operation. We just do sorted dict. Array index dash is the slow part that you can try fixing. Getting a slice is O of k, where k is the size of the slice. I've seen people pass with insort, even though insort is slow for O of n for each insert. Okay. I thought this was I thought it would be necessary though. But I guess like is like the length of the array just like you could do length of the array minus the index, right? I think, or something like that. It's either R opposite or I have it opposite. Or it's like the index minus length of the array. Because I think this is already just a property of the array. I guess I can just sort it again or run it again. I don't think I'm allowed to copy and paste this. Oh, I am? Wow, you think you're correct. It's the slicing. That's kind of crazy. I didn't think that would do it. Yeah, I didn't think that would do it. But yeah, the length in the store is constant. But then when you slice it, it slows it down more. Okay. Well, yeah, if it wasn't for this, then I probably would have just did the sorted dictionary. And I think that works. Is from what I heard, it's like very similar to a binary search tree. Although I think it just sorts the keys. Yeah. Okay, thanks. Yeah, this one was not bad at all. And I think like literally just from solving this, I don't know if I would have time to solve this one too, I think. So your algorithm is O of n squared right now. It's O of n squared because for every I, worst case, we have to perform an O of n operation. Yeah, like this is O of n. And then this one is O of n. Yeah, so this is O of n squared when you multiply these two, yeah. Yeah. Makes sense. Makes sense. I'll type in O of n squared for this. Yeah. Yeah, makes sense. Makes sense. Makes sense. I'm glad I'm like learning how to do this bisect thing. I didn't used to be able to do this like 50 days ago for sure, or like even like 20 days ago, honestly. Like 2 weeks ago, I would not be able to do this. I didn't notice. Did you click submit to see if it passed? Yeah, it passed. Yeah, I did. Yeah, it passed. It worked. Pog on a log. Pog on a log. Distribute elements. Leetcode hard. Supposedly. That one was not that hard. Not that hard. Just do some bisecting. Okay, and then I'm going to try to do the submatrices one. This one I struggling with. So my idea was to like, okay, I'll just expand out. So I'll like just start and get the maximum one from here. So we'll go, okay, here, here, and then we do here, like here. And then we like try to expand out and get like grids like this. The problem is though that we can have grids like this. There is an easy in-log-in solution using sorted list from sorted container sorted list. I don't even know what sorted list is. What's the difference between sorted list and and sorted dict. It's like a linked list. Or it's, how is it even done? How does it maintain? It says that, I'm looking, it says that the sorted list is like list, but everything is sorted. And that allows it to have like O of login for insertion, deletion, and searching for the element. So instead of calling bisect, my guess is like you could just call like dot find or whatever. But I'm curious how that's implemented. How does it do that? Like under the hood, essentially. Implementation wise. Yeah, AVL tree. Bro, that's crazy. Doing an AVL tree, why not just a binary search tree? Is it really that bad to do binary search tree? Like, it's not possible? Like, this is insane. This is like a hard problem. Just implementing an AVL tree off the top of your head. Jeez, that is insane. What? You can only do it with an AVL tree? A Ferent Fenwick tree? Oh my god. Like, I think implementing a binary search tree is not terrible, although it's like kind of bad, but like balancing. Binary search and login. Well, these people copy and paste templates, by the way. Yeah. Yeah, that's true. That's probably, I mean, I think that's what you'd have to do. So this is my idea, but I did not do binary search myself. And then he does the sorted list insert. But he made the same mistake that I did too, I think, when I said, this is like O of N to insert. He didn't even do call insort either. He just didn't even, I guess, just didn't even use the library. The time complexity is definitely O of N squared. In Rosis, what is up? What is up? What is up? In Rosis 94. I think that's how your name is pronounced. I think. I don't know. Wait, this passes? What do you mean what passes? That code? That code passes. Yeah, I think it just barely hits their limit. And it does pass. Just barely. I think. Sorted list maintains 3 internal variables. A list of lists. Sublist sorted. The second contains the maximum element in each. This is used for the fast binary search. How the F does n squared pass on n less than 10 to the 5th? Because it's not like people are going to get rejudged again. It's not, I don't think it's like actually, like I think it's, what is it called? It's like amortized time complexity. But basically I think that it probably depends on how the list is built. But I don't know. Where's the stupid thing? Where's that solution that I was looking at? Is it this? No, I don't remember where it was, and I think it's this one. Yeah, like I think it's kind of like I think the insert here. I don't know. I mean, like it might not. I don't know. Someone just said test case that would break ON squared, but Lee chose not to add it. Yeah, and only surprisingly too, only like only Whoops. Only 6,000 people even tried it, and then 2,000 accepted. I don't know how bisect sensor works, but that guy said it's linear. Yeah, because this isn't even bisect. This isn't even bisect. This guy is like literally splitting the list. He's like making a new list every single time when it inserts. Like it's cutting it in half and then like putting the new one inside, or like resizing the array, I believe. But I guess I don't know. Yeah, I don't know. Yeah, it's pretty weird. Pretty weird. We can't add the test case currently because of technical issues, bro. Leetcode needs to step their game up. I feel like it's not that hard to do this kind of stuff. Like I don't know. I feel like to be able to add test cases and things like that. Inefficient O and square solution pass system tests. The above code should receive a TLE verdict whilst it is accepted through attach max. Promptly relayed and dedicated team. We appreciate patience. Rest assured. Reach out to you. Yeah, I guess they probably will rejudge it. I guess they should. Probably one of the few times where rejudging would potentially help my rank. I don't see a reason not to have the test case. It's just simply descending order, sorted array. Yeah, so the descending, I don't know. Yeah, I don't know anything about, but yeah, they didn't have the good test coverage, I guess, for this one. But what if I couldn't have done this? Then I would have used the sorted dict. Again, I think this is like a binary search tree in Python, and or use a just implement my own binary search tree if I can't do that. And then I think that would have passed. But yeah, it's kind of interesting. Kind of interesting. And then you have this sorted list. Bro, the sorted list goes crazy. I didn't even know that was a thing. You just append and it's just all O login. Pure. Wild. Okay. And did nobody like even try implementing a binary search tree? You have to balance it or no? I think they just did that. Yeah, I think they just did it. I don't think you have to balance it. Yeah, okay. Anyways, okay. I think that's fine. Just want to see if you could do that without any balancing. Okay, and then count submatrices, top left element, sum less than k. I really don't want to do this one. I don't like traversing through this, but I don't know how to. I can extend it out. I can find like this deepest one here, and then all I want to do is literally just like maybe like do like here, here until it can't anymore. But the overlap is killer because shoot. So kind of sucks that I didn't do the Leetcode contest too. Bro, my rating would have shot up had I done this contest. My rating would have gone up so high. I would have done like the first problem so easily, and then but like the problem is I just don't like doing Leetcode contests at like 9 p.m. Normally I sleep like I'm way better in the morning, but bro, my thing would have gone up. But this one, I would have had 9 points. I don't know if I would have solved this one. I think I have faith in myself that I can learn how to iterate through a matrix, but let's see. I want to see what would I have gotten if I just straight up just got 9 points. I was just chilling. Oof, not good. Probably not good if I got 9 points. Okay, yeah, 9 points does not cut it because people were solving Q3. I mean, maybe I would have solved Q3 though. Who knows? Haven't even looked at Q3. Did you do Q2? No, I have not. I have not done Q2 yet. I'm stuck on it. I'm trying to like expand this out, but without having like overlaps. But like my code is not good. Uh, uh, just remember that if you use sorted list, use the sorted list built-in bisect methods. Yeah, you have to use append, right? Like the person did in the thing. Oh no, you have to say bisect. And then count. I range. Interesting. Interesting. This is add. O log in for adding. Crazy. Not O of n, O log n. Yeah, but if I did Q2, well, that's 9 points. That's 9 would be like 13 points, which would take me over most, I think. I don't know how much time you spend on Q2, but it's a good problem to solve. Maybe take analytic topics, could unblock you. Yeah. Like my idea for Q2 was like expand out, get the max size of this one, and then get the max size of this one, and then start trying to iterate through all of the diagonal combinations. But yeah, I think it is a good one. Yeah, you can solve all 4 for this contest. You should try solving them all. Yeah. Yeah, and so like I want to expand out. So like try like here and then here with full, and then here and then here. Um, or better maybe like here, here, and then we finish, and then we do full, and we finish, and it would basically just keep expanding out like that. I think there probably could be like maybe a DP thing where you like grab up, grab left or something, but yeah, it's probably pretty important to be able to traverse. Yeah, but the time complexity doesn't like it's like 1,000 for the link, so I think it actually works. At least that's my thinking, right? I was thinking, okay, well, we're only at 1,000. But yeah. Yeah. Okay, I'm gonna read the other one. I'm gonna read this one and see what this one's like. Minimum operations to write the letter Y on a grid. We say that a cell belongs to the letter Y, so it belongs to one of the following. The starting cell, the top left cell, and ending the center cell of the grid. The diagonal. Starting at the top right cell, ending at the center. Vertical line starting at the center, ending at the bottom border. All values at cells belonging to y are equal. All values at cells not belonging to y are equal. The values of the cells belonging to y are different from the values. Okay. It's a 0, 1, or a 2. Return the minimum operations needed to write the y. Given that in one operation you can change the value to any of the possible numbers. So we have a 1, 2, 2. But then we can just do this and change these to ones. And this one, we change all of them to zeros. What is this? Why are these blue? Why do we change them? After the operations, all cells that belong to y denoted in bold have the same value. Oh, because I think you can't have the same value as a y. Y has to be unique. And these zeros would mess it up. Y has to be unique. Okay, so this one's like, seems like it's like counting. You're just trying to count the numbers of values that are from, that start out here and drag out down to the center. So here, 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 here. And to maximize this, these changes, or to minimize the changes we need, we should just take the numbers that are probably take into account all the numbers that aren't a part of this, maybe with some frequency map, and then we just choose the minimum, the one that's like basically easiest for us to change. So in this case, it would be zeros. And there's a little too many zeros here, so we gotta flip those out that are outside of this box. So like, I guess an inside box, outside box. But anyways, that's my initial thoughts. Those are my I've looked at this problem for 20 seconds thoughts, or for about like 2 minutes, I guess. Seems like it's like some kind of like counting problem, counting frequencies problem. All cells not belonging to y are equal. So these are all 0. Okay. Yeah, so then how do we do the frequencies for this one? How do we be able to tell? We get the frequencies of everything in the box, maybe frequencies of everything outside of the box, outside of the y. And then how do we compare those? If we say there are 22s outside and let's see. We got like 2 examples, right? We've got like, let's say there's like inside, we have like some count, and we just like, okay, well, there, how many zeros there are, how many ones there are there, and then how many 2s are there. We're just like, oh, well, there's like no zeros. There are maybe 10 ones or something, and there's like 100. This will actually never happen because n is, we actually could have 100, but that's fine. Okay, then we do outside. I was actually thinking about this outside. And this one as inside. We just say like, there's this many. There's this many. Okay. So in this case, we just add them. Let's see. Okay, so we have 50 inside. Let's say we have 52s, but then we have 100 here. So this one's probably the best candidate for outside because it's the max out of all of the inside and the outside. So we would just keep those as 2s. And I think that minimizes everything. And then for this one, we say we have 52s, but like that's what we chose for the outside. So we just choose like something else. Should maybe ones, but like what if there's an overlap? No, but there's not because there's no overlap. These are outside and inside. So then you just change this to literally to anything. Doesn't really matter, but just do the math, which would be 50. So you would get 50 plus 10 as your final answer. So 60. And then in this case, like 1, 2, 3, 4. Let's try it, I guess, on this case and see if it works. So on the outside, we have 1, 2, 3, 3 ones on the inside. And then 1, 2 on the inside. And then on the outside, we have 3 zeros. Then we have a 1 and a 2. 1, 1, 1, 2. Like this. And then so we kind of have these chosen. So we say, okay, well, our outside max is 3. So let's probably keep it to that. Unless this one is greater than 3. And it's not. So we're like, okay, cool. So this is going to be our choice. So we've got to flip these and then flip these. So that'll be like 2 plus something. And then here we'll say, okay, 1 is our choice because it's the max here. And then we flip this one. So it'd be 1, which would be 3 total. Yeah. So it works for this case. You just grab the greatest one, see if it conflicts. See if there's a greatest one inside of here. And if it's not, then we kind of have our answer by just subtracting out everything that it wasn't. Yeah. Okay, cool. I think I can just do that. So I think you just iterate and create like an inside counter. So like outside, like counts. I guess you can use counter. And then okay, let me get this door. What's that? Sì. 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 Cosa viene? Okay, cool. Back. Yeah, I'm back. Okay. This one, another. So I think for the inside, we just. Just watch out for the diagonal. It might be basically just traversing through this diagonal till we get to the center. And then going down. I don't know how, I guess drawing this Y out. I don't want to draw the Y. Just can you draw a Y? Here, here, here. Do. Should I have, what's the best way to diagonal, diagonal, diagonal? And then once you're at the center, just go down. What's the best way to do that? I seriously have no idea. Could do a while loop, actually. Could just do a while loop. These are equal. So it'd be like while I is not equal to the length of, or R and J is not equal to like C or something. Which I think these are the same values, but like just N. It's the length of grid. And then we just keep jumping down the diagonal and then do the counts. So do like inside counts as you go to counter. And then we'll do like inside counts at value equals grid ij, and then we'll say like value like plus equals 1. Okay, cool. So this gives us the first part, and then we can start diving down once we're at the center. And then also probably take this. And these are divided by 2. Might be an off by 1 error here. I don't think so though, but I think this should be okay, but keep that in mind. And then do the counts plus equals 1 for this mid value. And then once again, we're going to go down this time. So put this as a comment. Start building the Y frequency. Top left to center. Center to bottom. And I would probably just prefer to mark these as seen. Honestly. Just mark them as seen. And then, but actually I don't even need to do this. Yeah, no, we don't need to. Just do this until we're at N. And the row will go until it is N. The column will go until it is 0. No, actually it stays the same. column stays the same. And then just the row just goes to n. Perfect. Perfect. And then we'll do top, right to center. So we'll do the same thing here. I could probably turn this into a function, but like, I don't think it's super needed. But here we're going to say they both start at n-1, go until they go to the center. But then this time we're just going to subtract. Like that. And then that'll work. And oh my gosh, this is like crazy long. Not equal to -1. Then we'll add the outside frequencies. Then we'll have the value. Kind of double looping, but I don't think it matters really. And then now with this, now we have the outside counts. And then we have the inside counts. So then we just do some logic to see what's the largest one out of both of those, so we can choose. Wow. I didn't even know they had this. I accidentally clicked this. Cool, so here we get 2 is 2, 0 is 2, 1, and then we have a -1. What the heck? I think it doubled up when I got there somewhere. Definitely gonna need to fix that. And then once we hit, then we break out, but then we do center to bottom. Oh, it's here. That wasn't supposed to be there. So we have 3 1s, 1 0, right? So inside 3 1s, 1 2. But I've got 1 0. Nice. Okay, let's see here. And I literally can't even comprehend what this is. This is 0 0, 1. Like what? Here, here. It should be -1, blank, -1. But it's 2. Oh, because it's 0 for the top right. Same 0. But then we +1. And we -1 here. There we go. Cool. Now we've got it. -1, blank, -1, middle, and then middle. Yeah. Perfect. ¿Cómo? Okay. All right, all right, all right. I'm back. Uh, almost finished with this thing, I think. Just have to, I think once just do some logic now that we have the counts on the outside and the inside. So we just want to minimize. We can minimize by comparing the greatest values of both. And then I think just taking that, because we can only have like I think we can only have one winner. So I think it's fine. Might be wrong here, but like it's just, at this point, just playing around with this. And then here, let me make sure 3, 0, 3. There's 3 zeros. And then we have ones for everything. Yeah. So I don't think there's really any cases where like you want the majority to win. So just grab the max of both. Take the max, or whatever both is, and then the second max for the other one. And then like everything that's not those, we just like sum them all together. The sums of everything that's not that key and like inside that one. So like we just get the max of both, which I think you can just do by like doing like dot. You could write a function. I think it's, fortunately I just have to just do it this way, key value in outside counts dot items. I don't know actually. I think, 'cause I don't really like that, but I could do that, but like I also want to sort the keys and the values. I think it's probably actually better I learn how to do that. Like I just look it up. Okay, so okay, cool. So because we're using a counter, okay, use this function most common. It's better that I actually learn how to have these. So most frequent is equal to like outside counts dot most common. We want the two most common ones. And then do something like this. Is equal to inside counts dot most common for 2. And then we can just take the outside most frequent and compare them. And then everything that's not it. Maybe that's, I think, let's see, what does this print? Most frequent Geez, I actually hate that these are named so long, but okay, most frequent outside, and then most frequent inside. Let's see what these look like actually. So we get a 0, 3, then 2, 1, then 1, 3, 2, 2. Okay, cool. So the first one's going to be the biggest one. If, or let's say first and second. And that means I'll probably have this one, not the answer, but like, I think it'll be the top, call it top, I guess, and then the second top, I guess. So we'll just say like, we just want to tag this key. So then we'll say like, okay, well the top key is, there should be a way I can actually do a max too. I think there's probably like a better way of doing this than the way I'm doing, but whatever. F2. And then like the second top is like it would be the second, I guess. I don't like the names of these. Something like that. Like if the inside is greater than, and then if it's greater than the outside. Then what we'll do is set it as the best key, and then take the second one as the best key, because we cannot have these. And then we'll do like else, which is default, and do the outside as the winner, and then the inside second as the winner. Okay, and now I just want whatever value that is not this key, and I just want to start adding it to answers. So like if it's not the thing here, then we'll just do here. And then what a like ugly, yeah, what an ugly solution, but whatever. Whatever. Return answer. Yeah. Okay, and then Put this one here. Duplicate this code. And I should probably like start solving these more like interview focused and like modularize the code, but so probably think about that for the future or try to remember that for future problems. Okay, so we have this one top, second, and then we'll just put the outside here and the inside here. Cool, and I think this will basically get everything that we need to change to get those most frequent ones. Might have a syntax issue, but let's see, we get 5. That's too much. Too much. See what this is here and why this is happening. Okay. So then here, okay, we got this, and then, or we just choose the biggest one, and then like say like, oh, okay, well, you're the biggest. So then let's just swap you to 0. And then let's swap you to 0. Hmm. 3, 2, 1. Oh my god. Okay. So let's see what's happening. Just don't want to grab the top one. Second top one. This one should be executing though. Hmm. Print answer. We get 2, which makes sense. Oh, because, oh man, because they're different. So it's actually cool. I can actually just select this one because they're different keys. Oh, cringe. Cringe. If top not equal to inside first. Or I hope this works. I actually have way less faith in this now. Way less faith in this. Dear God, I hope this was the right math formula. This was the right algorithm. Because I only tried it on one case. I didn't even look at the second one. Oh my God, it might work. It just might work. Oh, it does not work. Okay, I'm probably just gonna call it here with this one. Honestly, I don't know. Don't think I'm gonna keep looking at this. Two two zero zero. Like one, I have to draw this entire thing to figure out what does this thing look like. I see if it's a problem with this that I wrote, or is it a problem with this? Just a lot of playing around. A lot of playing around. This contest wasn't bad though. Not a bad contest. I really wanted to go through like some of these, but contest kind of took that up on me. How many choices do you have for Y and other? Will be. How many choices do you have for what Y and other will be? Probably 2 choices would be my guess. 2 to 4 choices. Like it could be the most common one here, or the most common one here, or the second most common one here, and then the second most common one here. So like 4 is what I would think. 2 to 4. Ideally, this is probably the ideal case where you just have like this one's the max is 0 and this other one's the max. So you'd only have 2 choices. But if they're equal, if this way there's like this many on the outside, right? Now it's a little bit different. So now we have to choose one. We have to choose one. I guess you'd probably want to choose the one that has the overlap, like the most overlap with the other one, maybe. So like this one has, there's a tie here, but this one has like a 0. But they're kind of already ahead on the 2s, I guess. So like you could flip the 2 and that would, could maybe like counteract it or something. Would be my guess. So there's like something like that. But coding that logic would be exhaustive. So that's probably not the case. Or I mean, it could be, but coding that logic out would be quite difficult with just a bunch of if statements. So there's probably a better way, would be my guess. Oh. There's a simple way to code this with how few choices there are. Yeah. What is up, Midnight Simon? What is up? What is up? There is a simple way to code this. I'm trying to do this contest thing. For right now, I solved the hard one that was on this contest like pretty quickly, I think. But that said there was like a bug in it, I guess. So they like allowed like O of n squared solutions for this. But I think I would have been able to do this using like a sorted dictionary, like in Python, like Python's library. Okay. There is I use Python for Q4. Oh, nice. You got the polyglot because of sorted list. I'm surprised you even knew that because I thought you only did C++. I didn't even know sorted list was a thing. Like I read out like elements of programming interviews. Yeah, B Becca uses Python. Nice. Also, you don't know why he's not streaming anymore, do you? Yeah, I remember. I remember him. Yeah, you told me he was insanely like disciplined. One of the most disciplined people. He's probably busy. Yeah. I'm gonna try to because I think I'm going to be like failing I guess I'm like kind of planning for it. Like I think I don't think I did good enough for the DoorDash one. So I'm gonna start like doing more content creation stuff because I have a lot more time now and just doing like I think Leetcode. I'm gonna try having like a stream schedule and stuff like that, but basically getting more organized for content creation. And I have a couple of video ideas that I want to like put more effort into, like with the video editing. I think we'll see how they turn out, but I have hopes. I think I can make something good. Nope, no other interviews. Nope, no other companies want to interview. Not in this market. I got to reach out to my friends and see if they can give me referrals. But yeah, I think I'm interview ready. I got the system design down. Got the Leetcode down. So I think I'll be good. How many places have I applied to? I don't think cold apps are just the way for this job or this job market. I can show. I think I have like the Google Sheet where I do all the apps, but let's open it up. I think probably put this on stream too, but so like here's some things. Okay, so like one, I've got two sets. So here's me applying since like January, I think, maybe December. I had a Meta recruiter reach out to me, just because like I had asked somebody to give me a referral. So really those are the only ways I'm getting referrals. Basically, it's just the only ways that I get interviews are from referrals. So here we got this, like I applied to these. Probably all in one day. Probably like January 1st or something. And then Google didn't get anything from Google. Only reason I have a Google interview now is because I have a referral. The apply to these. All of that to say is that it's probably about like 80. This was a January 30th, so I haven't applied to any companies as in like the past like 2 months, basically, more or less. Let's see, but this is for this one, right? But like the reason that I'm like so kind of against doing cold applications, I think in this job market is because of this. So I've got all these startups I think that I applied to. Really? Oh, that's not even that many. I feel like it was way more. Okay, anyways, I feel like it was way more. But these are like a ton of startups I applied to. And didn't hear back from really any of them. Except for Amazon's OA, but like uh that was it. And then I think I have like, so this is 200. That was 200 startups. But wait, let me see. I think I had something. I thought I had something that was more. But this was in September. Sorry, I'm getting really tired because I've been doing this thing for like 2 hours. Doing this Leetcode stuff for like 2 hours. Hmm. Where is it? Where is it? Where did I put it? The heck did I put it? I literally had like all the results for my thing and oh wait, it's here. Okay. Okay, I'm crazy. I'm crazy. I am crazy. Okay, cool. Okay, yeah. So here's like, and here are the results from those. So we had about 200 applications, about 200 applications. This is around September, I want to say, and I only really had like out of these 200, and these were startups, so like they're not even paying that much money. They, not to say that all startups don't pay money, but it's just that you have to kind of decide the startup that you're doing. So here we go. Oh, I even categorize these, I think. I applied to 100 startup applications on Wellfound. I use this recruiting service. They apply to jobs for you. So they applied to like 150 for me. But I don't think they were good at all for whatever reason. Like they just really sucked at choosing like good jobs. The jobs have to be like when you're applying to cold applications, you want your jobs to be fresh. You want your actual skill set to be listed on the job board. I don't think these people did any of that. So 150 got 0 interviews from that. Wellfound 100. I got 3 interviews from that, but like 2 of them were just really bad companies. Like they're like these startups that like I guess they're like what is it? I think it's like some meme or something like stealth startup, but basically just like secret startups. They're trying to like be low key, but also I guess get like good talent, but like they can't really tell you a whole lot about them, and their equity is probably worth nothing. Anyways, so job board sites like 100 got like 2 interviews, so probably I guess like a 2% is what we're looking at for cold apps. I applied to DoorDash too, cold app, and got that. And then so we got Upwork jobs, and I can convert really high on Upwork, but the pay is not good. And then Y Combinator, that's like 2. Yeah. Anyways, all of that to say is that like this is my applications process. The people who had, yeah, for sure. No, for sure. Like you got to keep applying. You got to keep your resume at the top of the stack because like they have different job boards. You just wanted like the fresh ones. So yeah, you just keep applying. If I did that, my guess is it's like still 2% chance. Like there's just if I had referrals too, that probably rises up to like 40%. My guess would be. But yeah, that's why I think it's just better for my time. I think just do referrals. But that said, it doesn't take that long to apply to jobs. And again, not that cold apps are I guess never possible, but like I used cold apps and got 1 company out of like 100, so that's like 1%. It's like a 1% rate. I'm really curious, like, and I would love to see like how does Fang affect like your interview rates. I'm gonna try to do something like that. That's gonna be another video in the future. Is that like I'm gonna make 2 resumes and I'm gonna like send out one that has Fang and then another one that doesn't have Fang. Getting interviews at interesting companies is hard right now. Yeah. Yep. Gone are the days when Amazon recruiters were like hopping into your LinkedIn DMs, like just saying, please interview, please interview. But now it's like, now it's just not the case. But yeah, anyway, so that's like that's my job. I think that's my plan is that I'm just gonna like send out try to get some referrals, see what happens. Get some referrals, see what happens. And I might like look through these again. I have like the email format. One thing I would love to have is like the email format of all of these companies so I can start directly emailing the recruiters. And I would totally do that. I would like rinse and repeat because then you can just get another person who's looking at your resume. Like my guess would be that you can drastically increase the number of times people view your resume, and then as a result, your pipeline gets larger for the actual like setting up an interview. Just like yeah, it's just all pipeline stuff. Anyways, yeah, I'm vibing, just vibing. Here, okay, here and then okay, so here we have these inside and outside counts. So I think there's a it's not like Zombie Whale was saying that there is a fancy way, a not fancy way of returning the answer. Are you applying to only East Coast positions also? Nope. I don't care. I don't really care. I think like I really ideally would just want to work in a place that's like San Francisco or New York City, but don't really have too much of a preference. I mean, I think what's gonna happen is that I'll be in either San Francisco or New York City. I think just because those are where the most tech jobs are. And then San Francisco because there's a startup culture there, so I could meet like a lot of people who are kind of into all that stuff, which would be cool. Which would be cool. SF probably has more offerings. Yeah, for sure. A lot of startups, a lot of tech, for sure. Wait, what is this? 11. What just happened? What did I do? This code was good. Oh, it's because two cases are being run. I think, do I just base it off frequencies? Hmm. Yeah, another thing too that I've said, like I said it like a little bit yesterday, but I'm not too worried about like just not having the job. Like worst case, I'm just gonna be, working on content creation, or I guess focusing on content creation. So like, and I've also said it before, but I think it's a skill in itself to like, know how to make like a good video and things like that. And I think both skills are gonna help me, but like ideally I would be working now so I can probably like speed up the process, but yeah, I'm still good. I have like I could literally not have a job for like a year, I think, and I would like not be dying. And then if I really wanted to, I guess, but like even then, like in a year, like I could probably be making money from content creation, like just like $1,000 a month, I think. Jeez, okay. So if we have three on the outside, three on the inside, then we just choose the one with the least amount of these. Yeah, I'm not really sure what that thing is. I would just like I think it just makes more sense. You just check these. I don't know. I don't know. Probably just give up on this one I think we're at this like 2 hour mark of me solving stuff. I gotta decide what I'm gonna do now for like the rest of the day until like 5 p.m. Probably I'll Leetcode again at like 5 p.m. Just get more practice in, and then you want a hint? Yeah, sure. Because I mean, like I said, I'm gonna close this out and then probably look up the solution um afterwards. Think brute force. Um taking every combo, taking every combination and getting the minimum of those. So you try 1, you try 0, you try 2 with, and then like you do like 1, like basically getting the sums of all the numbers. So like 1 and 3, and this would work because the lengths are so small. So you can get like 1 with like this one, which would require you like summing these and summing these. And then you do the same thing for like this one with this one. And then you like get the sums of these, of all the ones that like aren't. So you can have what, like 3. I'm not sure if you, I'm trying to see if you can like generate combinations, but I don't think that you can do that. Because you need sums of like the ones that aren't included. Like you do like 3, but don't think the combinations, I'm not really seeing it. Okay, yeah, but I don't know what else I'm gonna do. I'll probably try to do some recording for that video actually. I'm gonna try to make. I think I also don't even know what the name of the video is gonna be. Like what? I kind of wrote out an outline. Wrote out an outline for the video. See if I can find it. Mm. And whoops. We have to take 3 and then sum everything except for this one. And then everything except for I. And then do these again. So maybe this one's like a what, 4, like a nested for loop. So like 4 I in range up to 3, 4 J in range. I guess like the length of n. in like in dot items for k in range or in m dot items, and like answer is equal to like the min of like answer and like current sum. Like that. And then you have like an if statement, so it's like if I not equal to j, and then if k not equal to j, but I don't think that actually works. Maybe it does. List has no object items. Well, that's fun. Current sum, not a thing. 0, 1, 2. I guess it doesn't exist for this one. So equals math.env. Nope. Not it. All this would go over every combo, but it might be because the counters don't always guarantee to have 0, 1, and 2 inside of them. I could initialize them here though for the keys. Oh, I didn't see that also, but just try all the possible options, nested for loop. Maybe it goes here. Nope. Go through all the n ones, go through all the m ones. Add every value as long as we're not taking from the same one. So it would go through 0, like with 3, 2 is 1, 1 is 1. And then we would go through here. And add all of them where j and k aren't equal. So do we maximize it then and we just don't minimize it? But I think it should be not. I think it should be minimized. Because we want the minimum number of operations. For sure, for sure. Okay. I was gonna look at this video thing too. I'm just gonna call it on this problem, and then that's it. That is it. That is it. Almost, but not quite. For I in range 3, for j in range 3, if I not equal to j, calculate how many changes are needed. Great, that's what I did here, but for 3. So get rid of this. I mean, I feel like this should be the same thing though with my dictionary. These have 3 elements. And they also have the values of all of them. I feel like this should be doing the same thing. The only difference is just that like I didn't initialize it all to zeros. So we've got like this one here, but then this one doesn't. This one's missing a 0. But like if I did inside counts at 0 is equal to 0, that would initialize it. But I still think we phases that error. So now we get 2. If I not equal to j, calculate how many changes are needed. Right? Like this is like, I mean, pretty close to what I wrote. If it's not equal. The only difference is I had that I loop. And then I'm always checking the current sum with the value. But this time I like initialize current sum to like 0, but I mean, maybe I messed this up. And this is going to be too big of a number because these two things cannot be the same. They can't be the same. You need a nested loop for I in range, for j in range. Yeah, that doesn't make any sense. Oh boy. Like this is literally the same code though. You start with 3, right? Iterate 3. And then add up all of these that aren't like the same as like this 0. Oh, but we don't actually count this one as a change too, right? We should sum all the numbers that aren't. I think that's probably where it went wrong with this. Is that this is setting the value. This is setting like 3 here. But it should be everything that's not. So plus equals here. And then after the end, we like set the current sum to 0. Again, when we do the next one, that's the problem, I think, is that we go 0 and then sum all of these and then sum all of these that aren't 0. Something like that. But nope. Nope, it should be 1, 2. And then it should be one of these. Whatever. Yeah, okay, whatever. I don't care. We'll do that later. I can't. I'm not gonna spend like just an eternity thinking about that. Okay, and then I'm trying to look at these videos, things I'm gonna be doing that I have to do. So where is it? Hmm. Hmm. This is what I did. I'll take a look at it. Okay, yeah. I remember this one. Don't remember what I'm gonna do for the video thing. So you did the counts, and then once you had the counts, you did a loop, and then you took num y cells. So you counted all of the y cells, and then just subtracted them. So this makes it simpler because you don't have to sum every single thing, right? Like I was saying, oh, I need to sum everything. Here's why I have this code here, so I can sum. But like, you have the total sum, and then you just subtract. I think that's like that's pretty big, because then you don't need yeah, you don't need like the triple nested thing that I was doing because I was gonna sum like this combo, these two, with like these two, and then et cetera, et cetera. Yeah, just subtract like the total number of cells to get the sum immediately. Sounds good. Yeah, it sounds good. Sounds good. Where's I? Okay, I'm gonna close down and stop Leetcoding. I'm gonna try to might try, I don't know. I have like some videos that I could edit probably into something. So maybe I can just try doing that instead of like making a new video, or maybe I'll just do recording. I kind of want to get something out that's like pretty good. But I guess I'll just plan around that. And then at like 5 p.m. I think might start streaming again. If yeah, I guess it depends. But yeah, and then I guess this time can go back into doing these rando problems. Okay, cool. Thanks for the help, Zombie Killer Whale. Thanks for stopping by, guys. Watching me solve some Leetcode. You guys were, I guessing that you guys were also probably solving them too, or just hanging around. I don't know. But yeah, thanks. Thanks for the help. I'll see you guys later. Oh, also, I guess in either today or tomorrow, I'm gonna be hearing back from the results of my interview. So like, that's always fun. So either today or tomorrow, I'll know if I have a job or if Google decides to hire me. Not hire me. They're not hiring. Move me to on-site stage. So yeah, I got those things coming up. All right. Praying hands. Praying hands. Let's see. All right. Yep. See you guys.